I want to talk about the rules for a normal distribution and how they can be useful for us. Um, so just to rehash what they are, um, this is a approximately normal distribution. We've got mu for the mean, it's a population mean. And then we've got mu plus sigma, so that's one standard deviation above the mean, it's two standard deviations above the mean, and then on the other side, one standard deviation below the mean, two below the mean, etc. And we know that the area under the curve, so the area under the curve between the mean and one standard deviation above the mean is 34%, also 34% one standard deviation below the mean. And you'll see from the example that we can simply add these up to get some really useful information. So let's imagine you're doing an introductory unit here at VU, HHB 1104, and your overall grade for that unit was 75. And you're also told that the mean grade for the unit was 65 and it had a standard deviation conveniently for us of 10. Um, and you're also told that the distribution of grades is approximately normal. And so you want to know what proportion of students scored better than you, and what proportion of students scored worse. So back to this figure. Now that we have the mean and we have the standard deviation, we can simply plug those in. So remember a mean of 65, standard deviation of 10, so it's just 10 plus the mean. And then two standard deviations is 20 above the mean, etc. And this is you, so you scored 75. And to work out what proportion of students scored worse than you, you would simply add up these percentages, and then to figure out which proportion or portion of students scored better than you, you'd simply add these ones up. So I've done that for you. Um, so 75 is your score, and adding all these up equates to 84%, and then adding all these ones up equates to 16%. And so you now know that your grade of 75 was better than 84% of students, but not as good as 16%.